Air Vice Marshal Anil Gulani, DG Caps. Check 1, 2, 3. Air Vice Marshal Anil Gulani, DG Caps. General Ravi Arora, Chief Editor IMR. All the distinguished guests, ladies and gentlemen, a very good afternoon to you all. At the outset, I would like to thank the Master of Ceremonies for the very kind introduction given for self and my co-panelists. And I would like to put it on record that I consider it a pleasure to be here today, to be chairing this 4th session of the CAPS IMR Air and Missile Defense Seminar and Exhibition. I am certain that though it is the 4th and the last session of the day, it is not the least of the sessions, and that it will be an interesting and a fruitful session. Chairing of the last session of the day is always a tough task, and it always fraught with dangers, because the earlier speakers may have stolen your thunder by having covered already major points that you were covering, and also the fact that at the end of a day you may find that some of your speakers do not land up, like today has happened that 2 of the speakers are unfortunately not here. Also, at the end of a long, hard and arduous day, retaining the attention of the audience becomes a very difficult and a very taxing job. However, it shall be our endeavor. Welcome, Charan. However, it will be my endeavor, along with that of my co-panelists, to ensure that we keep this session as focused as possible and try and make it as interesting as well. Just a couple of points before I hand over to the panelists to give their talks, just to try and focus on the major points of this session. I would like to bring out what are the present challenges that are being faced by the air defense, which in turn will guide what is the research and development taking place and what is the future roadmap for the 3 services. As was covered in the morning by the AD commander, the term air defense is a huge term and covers the entire gamut of operations of the Indian Air Force, both during peacetime as well as during operations. And it is an activity that is a 24/7, 365-day activity, and a task that is given to the Indian Air Force, and which the Indian Air Force has been performing with aplomb all these years. It is a task that requires you to be able to ensure that the entire airspace of the India is at all times protected. And this is from the low levels to the medium to the high level, and now extending into the near space and the space as well. And the gamut of targets that are there, the range of targets that are there would be from the slow moving to the transonic to the supersonic to the hypersonics. There's a huge variety of targets and variety of speeds that are there that the Air Force and the air defense needs to look at. The recent study of all the recent campaigns that have been on and are still ongoing, the Russia-Ukraine war, the Israel-Hamas conflict, even the attack, the drone missile attack carried out by Iran on Israel on the intervening night of 13th and 14th April this year, codenamed Exercise True Promise, clearly brings out that the kind of aerial warfare has changed and changed dramatically towards that. There is a preponderance of unmanned aerial systems which are impacting the aerial warfare. There is a wide variety of drones that have come in. These vary from the miniature to the mid-size to the large-size drones. There is an increased usage of armed loitering munitions. There is increasing use of the adversaries to try and saturate the airspace with simultaneous usage of kamikaze drones, cruise missiles, ballistic missiles, the works. There is usage of hypersonic missiles, stealth aircraft, the usage of directed energy weapons like the lasers, which is being used by the Israelis in their Iron Beam, and which was successfully used during that night of 13th and 14th by them. Use of proliferation of precision weapons, and also the usage of add-on strap-on bomb kits, which enhance journal iron bombs into glide bombs, and thereby the launch ranges, and keep these launching aircrafts outside the launch envelopes of the ground-based surface AD weapon systems. Apart from that, there is the advent of swarm drones, the use of artificial intelligence, machine learning, and quantum computing in autonomous unmanned aerial systems, the proposed usage of manned-unmanned teams and the loyal wingmen in the future. All these have thrown up new challenges to air defense, and all of these are presently being grappled by the designers and the manufacturers of the air defense systems. I am sanguine that in the days to come, that we shall have solutions to not only these challenges, but even the challenges that get thrown up in the future. Another point that I would like to stress on here is that over the last 2 decades, the Indian air defense system has seen a vibrant change with the induction of indigenous technologies and certain new air defense systems. It has improved significantly, but there is still a lot that needs to be done to try and bring it up to the best in the world. A point that has often been said, and which I would like to reiterate here today, and in fact it has been said by several speakers in the morning as well, is that the entire air and surface AD assets of all the 3 services, as well as other paramilitary services and the civilian assets, need to be integrated with each other. They need to be talking with each other. The IACCS of the Indian Air Force is to a certain extent been integrated with the Akash Tir of the Indian Army. But have we been able to integrate the Trigun of the Indian Navy and the civilian assets? Our question mark remains there. And this is an area that we definitely need to work on, so as to ensure that we have an integrated air defense system which is able to provide you with a single composite recognized air situation picture, and which is controlled by one single command and control system, so that the entire airspace of the India is being scanned at the same time. As and when there is any intruder coming in, he gets detected and allotted to the best suitable weapon system, irrespective of the service, and he gets taken on. So having said these 2 major points that we need to focus on, I would now request my speakers to please give their views. First and foremost, I will request Air Commodore Ran Singh to please give his views on the integrated air and missile defense roadmap for development and acquisition.
Thank you, sir. A very good evening to all audience. To highlight the importance of this seminar, I must begin with a quote by of late President APJ Abdul Kalam Azad, who said, "A strong air and missile defense is the backbone of India's national security," unquote. Therefore, protecting national airspace and territory from aerial threats and ensuring security and sovereignty of our country is the prime responsibility entrusted to the three defense forces. Airborne threats in the present day have been evolving continuously using niche technology, necessitating innovative ways to counter the emerging threats. Keeping this in mind, I shall be covering the roadmap for development and acquisition intended to bolster integrated air and missile defense of the Indian airspace. I shall be touching upon the basic evaluation of aerial threats, thereafter importance of self-reliance through indigenization, the latest acquisition of weapons and combat enablers to counter the aerial threats, and thereafter the challenges faced by the three services and specifically by Air Force employing the weapon systems to achieve the desired air defense cover for which innovative approach to Indian industry is solicited. The rapid evolution of technology has led to development of standoff weapons with precision capability, enabling us to hit targets at larger ranges with much higher desired accuracy. Therefore, such threats have to be countered at much larger ranges, and a commensurate increase in the ranges of air defense weapons is the need of the hour. Modern unmanned aerial vehicles have diversified into different domains, ranging from hail, mail to low-cost micro UAVs. They are capable of carrying out multitude of operations, including aerial surveillance, combat operations, reconnaissance, and have enhanced maneuverability and strike capability. The incorporation of artificial intelligence in the latest development of weapon platforms, which has transformed UAVs into autonomous weapons with the capability of making split-second decisions and executing missions with precision. AI-enabled swarming autonomous drones have become a reality. These drones are versatile, mission adaptive, and can produce sufficient saturation to overwhelm any modern air defense weapon systems. The electronic warfare capability, including jamming and signal manipulation, has progressed significantly, offering sophisticated means to disrupt and counter adversaries' communications and radar systems. Improvement in navigation and still features of modern cruise missiles have made them capable of operating at nape of earth levels, making them more accurate, lethal, and progressively difficult to detect and neutralize. Our immediate adversaries have also developed credible hypersonic technology, which presents unparalleled speed and maneuverability. Deriving solutions to counter them poses a significant challenge to the traditional air defense weapon systems. Threats from the space domain, including ballistic projectiles, kinetic and directed energy weapons, have further escalated. This necessitated advanced air defense strategies to protect assets on ground as well as in space. Therefore, rapid development of indigenous technology is the necessary to ensure a credible and robust air defense for the protection of our VAs and VPs. To achieve this, the sensors and weapon systems capable of countering and preventing threats are required. The Indian Air Force has been progressing multiple cases to acquire weapon systems as countermeasures to such emerging threats. Indigenous development of long-range surface-to-air missile like Kusha, medium-range SAM Shaurya, short-range Akash NG, the QR-SAMs, integrated air defense weapon systems, the V-SHORADs, and the close-in weapon systems are under progress. and these weapon systems are likely to materialize and be inducted into service in the next 2 to 5 years. We are also acquiring modern mobile communication systems, handheld SATCOM system, small form factor ESM platforms, and integration of all these weapon systems in the network tactical domain or the nodes is being progressed. However, we do have our share of challenges, which include weapon system being incapable of protecting and operating at higher altitudes and low temperatures. The power supply systems at present lack the desired reliability, ruggedness, and portability to operate in such high environments. We face issues in cooling and heating systems and which are adversely affecting the health of our weapon systems. The anti-static systems are also a cause of concern. Solutions are sought for the mobile anti-static systems and high-altitude power plants for the weapon systems from our private industry and partners. Camouflage, concealment, and deception are definite force multipliers which enhance the survivability of weapon systems. The present IR nets in use are quite bulky. They lack their desired reflectivity in radio spectrum, making them susceptible to detection by SAR systems. Therefore, portable multispectral decoys which mimic the signature of radar, visual, and IR are also required for the services. Design and development is under progress to develop metamaterial-based synthetic aperture radar denial camouflage solutions. However, the products developed are too cumbersome and bulky to handle in the present form. We have an urgent requirement of high-speed, high-altitude targets to assess our air defense capability for undertaking trials of future weapons which are being inducted, as well as training of our op crew. With the increase in the number of air defense and communication systems, electromagnetic spectrum is becoming increasingly cluttered. Therefore, there is a need for AI-based solutions to effectively manage and coordinate simultaneous operation of numerous weapon systems. Having a robust communication network is the key to success of any mission. Leveraging 5G technology and including AI-based cognitive communication networks and enhanced real-time transmission capability, facilitating accurate data delivery to the intended recipients with minimum latency and high reliability. Security of data in communication is an imperative factor which can be realized by employing quantum computing-based encryption to safeguard sensitive information and ensuring secure communication channels amidst the evolving threats. To optimally employ the available communication network, and AI-based cognitive communication technology is required from our industry partners, which will enable intelligent data transfer using an adaptive network and seamless coordination amongst diverse weapon systems, enhancing thereby overall efficiency and situational awareness. SAM systems are deployed in remote and difficult areas. The vehicle platform plays a significant role in mobility to remote locations. A robust off-the-road capability of light platforms is required, which is low on maintenance and high on reliability for most of our air defense weapon systems. Lastly, tapping into the future technologies which include directed energy weapons, electromagnetic projectiles, and soft kill options involving an EMP pulse or active jamming is desired to counter low-cost, high-density aerial threats. To conclude, India's integrated missile defense is focused on developing a robust and comprehensive air defense system. DPSU and private industry partners to counter the challenges mentioned to become a self-reliant, self-sufficient, and self-sustainable force for the defense of our Indian airspace. I would like to conclude my presentation by a quote from General Rawat, and I quote, "The best defense is a strong offense, and India's air and missile defense is the best defense." Thank you. Jai Hind.
A very good afternoon to all of you. First of all, I apologize for landing up a little late because, you know, the Navy ships take a little while to navigate. We're not as fast as the Air Force. So kindly pardon me for, trying to gather my bearings right. And I ended up actually in the center of the CAP's main building, sir. And there, to my horror, I realized this is not the venue. So I had to really rush up, and finally I think I took a no entry and I managed to enter. Thank you so much, sir, for inviting me as a rep of the Naval Headquarters to impart my views on the air defense. I think it's quite prudent to understand what the naval air defense is all about, and that is why I stand here to share some of my thoughts. I'm Captain Charit Kapil. I'm representing the Directorate of Staff Requirements at the Naval Headquarters, which deals with the identification and induction of new capabilities to meet challenges of emerging and contemporary operational requirements. This is something which is our job, and this is how we manage our working hours late in the Naval Headquarters. I'm here to present a very short talk on the air defense, the Indian Navy. The presentation is divided into two parts, and the first part primarily covering the concept of the air defense at sea, and the subsequent part would be the capacity building which is being progressed by the Navy. Coming to the IAN's air defense philosophy, the air defense in maritime environment is quite similar, yet manifold different than the AD concepts of Army and the Air Force. There are numerous challenges that the sea medium poses for the air defense. Primarily among them is the presence of large number of neutrals owing to the freedom of the navigation and overflight on the high seas. The maritime environment in itself is challenging with limitations of sea state, weather, clutter, very harsh marine environment, and of course the radar horizon range. Naval fleet primarily relies on self-defense against aerial threats, operating well beyond the radius of the shore-based AD, which is handled by the Air Force. Further, the threats from the missiles are posed from all domains, including land-based launchers, as you've observed in the Ukraine-Russia war and the sinking of Moscow, enemy surface ships, submarine and aircrafts. I would now like to deliberate upon the various factors that complicate the air defense at sea, that is, attack vectors, identification aspects, target-induced complexities. The types of vectors which possess capability of launching anti-ship missiles are as flashed. First, airborne platforms include long-range LRMP aircrafts, which are the maritime patrol aircrafts, which actually possess the capability to seek and destroy the ships at sea. Land-based and deck-based fighter aircrafts, helicopters, and of course, the common advent of the unmanned aerial vehicles, which has actually complicated the situation at sea as well. And what we see right now in the troubled waters of the Red Sea and the Gulf of Aden, we see a lot of proliferation of these unmanned vehicles, which are really complicating the situation. One doesn't know which side it is headed for, and suddenly you find something coming onto you. So this is something which is really complex. Secondly is the surface combatants, which include ships of different class of missile boats, corvettes, frigates, and destroyers. Then is the underwater domain, where detection of submarines itself is an extremely challenging situation. Further, nuclear propulsion and the AIP technology in the conventional submarines have complicated the tactical picture at sea because the submarine doesn't surface at all. So you could have the kind of a missile attack coming onto a ship from any direction. And these are long-range ones as well. Lastly, the shore-based batteries of long-range missiles can also engage the ships at sea. However, all these things that I've mentioned, all the 4 things, they all require an accurate targeting data. Okay, identification. Even though iron possesses long-range detection capabilities, identification of friend and foe still is an extremely challenging situation. For example, any detection of fighter which could be classified to be as F-16 based on the electronic signatures could be well of US, Pakistan, Saudi Arabia, Singapore. And similarly in the Arabian Sea, Pakistan and Japan both operate P-3CI Orions. So one really doesn't know whether the aircraft which you have identified as an enemy aircraft really belongs to the enemy. At sea, formation of ships depend on their own integral sensors for detection and identification of aerial targets, which is assisted by the same ADS Bravo, which is used worldwide, or the IFF to some extent. Now coming to the target-induced complexities. Aerial threats which are present at sea varies from their attribute. Anti-ship missiles can follow various trajectories to engage the target, such as the sea skimming flying at altitudes of 3 to 5 meters, or something about 50 to 80 meters cruise trajectories, or ballistic missiles which come almost at an angle of attack of 70 to 90 degrees. So additionally, other threats than the missiles that I've mentioned are the drones, or the new advent of the loitering munitions, which have extremely low RCS. They have a carbon composite body, and it flies at various altitudes. It can confuse. It has confusing parameters. So it's extremely difficult to understand their angle of attack or their nature of attack. Operations of weapon sensors at sea is very much dependent on the geopositioning systems, and there exists a need to undertake operations in the GPS denied environment. Of late, Navy has been embarked on operations in a complete GPS denied environment where we are training our crew, we are making our systems redundant to make sure that even if the GPS is denied, our systems can operate. The anti-air warfare area shown in the diagram is prescribed by the operational commander, within which the anti-air warfare measures are taken and which is kept under constant surveillance for the purpose of instituting such measures. The high-value unit to be defended is located at the center of the area, surrounded by concentric circles of AD consorts and associated weapon ranges. The outermost layer belongs beyond the range of the surface-to-air missile is defended by integral fighters. These fighters are launched, of course, from the carriers. Thereafter, the target is engaged by the medium-range SAMs, something very similar to what the Air Force also has, the MR SAMs. And moving closer, we have short-range SAMs, and closer to which is the engagement of the target is undertaken by the MR guns, the CIWS systems. We also have the PDMS systems, Barak 1s, so on and so forth. Measures both hard kill and the soft kill, which include chaff and the off-board decoys, are utilized in an integrated manner within the ship and between ships to provide an effective and a total air power umbrella. Having broadly seen the AD philosophy of the IN, let's take a look at some of the key capability building measures being progressed by the Navy to achieve seamless air defense at sea. First is the MRSAM MF-STAR system, which is a joint development between the IAI and DRDO. The first system was inducted in 2013, and since then the system has become the mainstay of the Indian Navy's fleet air defense. Prominent capabilities of the system includes joint targeting coordination, which enables coordinated and effective utilization of air defense resources and the ability to handle multiple targets concurrently. Indian Navy is extending the air defense bubble at sea with the development of long-range SAMs with ranges in the excess of 250 kilometers. The LR SAM under Defense and Development by the DRDO will provide the Navy with the capability to address airborne threats including short-range ballistic missiles. The system is planned for induction on major combatants in the Navy. The important thing for us to understand here is you need to kill the snake before it lays the eggs. So any platform that is approaching the formation at the sea, it is important to neutralize it before it launches its weapons. So this is something that is the philosophy of the Navy, and this is how we generally try to take on the incoming airborne threat. Moving next, Indian Navy has various short-range SAM systems currently in service. Development of the indigenously developed vertical launch short-range SAM, or the VLSR SAM, is being progressed with assistance of the DRDO. The system is presently at the advanced stage of development, with the trials being undertaken both on board the ship as well as Chandipur at sea. The system will cater for short-range point defense requirements and is planned for induction by 2026. However, you realize that every time you cannot be expending the important SAMs to neutralize the low-cost drones and the loitering munitions which are approaching a ship. That's a challenge which has been felt even by the NATO countries as they are undertaking the operations in the Red Sea. So there comes a solution of the direct energy weapons, where the trials are still on, which we all know is undertaken by the chess DRDO. So these direct energy weapons presently are, for which the trials are undertaken, are of 2 kilowatt, and slowly it's going to be progressed up to 10 kilowatt. And what they have promised is that they would take it up to 50 to 100 kilowatts. So, something that needs to be understood is that unlike the land-based systems where size doesn't matter, for the naval ships it's extremely prudent to fit and rather to custom fit these big size equipment into a very small space on board. Whether it is the cooling system, or it is the size of the laser, or it is the power supply requirements, which are extremely critical when it comes, because everything is at sea, is being generated, so one really can't demand as much power and as much size as one would like it to be. So developing these weapons is not as easy as it looks to be. It certainly is going to take some time, but if that happens, it's going to be a game changer. Moving to the counter-drone systems, it is pretty much similar to what the other services are following, and as we can see that they are extremely cost-effective. They need to be cost-effective to shoot down the drones so that we don't expend our important ammunition. Further, the usage of drone in Russia-Ukraine conflict is signaling the setting trend of standard exploitation of such capability to gain advantage over the adversary. Indian Navy is, of course, actively inducting both hard kill and soft kill measures, and is also progressing various design and development projects to enhance the counter-drone capability. Further integration of the counter-drone system capability with the DEW and the CIWS is something that we are pursuing. And the similar challenge, as I explained, for the DEW also comes for the counter-drone system, because if one has to jam any of the incoming drones signals, the RF signals or the GPS, we would also end up jamming our own systems. So there is something which is extremely complicated, because you have one mast of the ship in which all our sensors are fitted, unlike the land-based systems where it is spread over a certain distance. So, development of these systems coupled with the harsh marine environment, the extreme salt and humidity in the air, becomes a big challenge for the companies. Finally, to conclude, the rapid advent of the air defense challenge demands concurrent development of counter technologies to remain ahead of the curve. Therefore, the course of the Navy is really steady on leapfrogging rather than tail-chasing research and development, and inducting cutting-edge technologies and innovation. Concurrently, indigenization is an unwavering long-term target with impetus to impactful outcomes in pursuance of self-reliance and our own Atmanirbharta projects in all our domains. With this, I conclude. Thank you so much.
The Chair, ladies and gentlemen, a very good afternoon, and I am the only person, or possibly one more the concluder, between you and breaking off from here. But I'll try to do the best. We've just heard some of the brilliant minds, subject matter experts, give out the contours of the air threat as it exists today. And they've also related the air defense-centric lessons which we have learned from certain ongoing conflicts. My job today in front of you is to piece together these insights and tell you what they mean for the Army or the air defense in particular, and crystal gaze a little in future. While doing so, I'll be careful to limit my talk to the primary aim of the Army Air Defense, which is the air defense of Army-specific VAVPs in the tactical battle area. I intend to do so using help of these certain slides, which are pieced together in these three parts. Coming on to the first part, we have spoken a lot about the air threat as it exists today. It ranges all the way from what is shown on the right and top of this slide, that is the hypersonic and the ballistic missiles, to what is seen towards the bottom of the slides, to the bottom left of the slide, that are the drones and the loitering ammunition and everything which comes in between. The recent, or rather the recent Iranian airstrikes have indicated that all these threats may manifest together within a very short moment of time. In addition, the ongoing Russo-Ukraine conflict has brought the veritable drone, which used to be something which used to see in marriages, as CNN brought the cruise missile onto the TV. Now these drones are right on our TV screens. These first-person view drones have become ubiquitous. Both the sides are using them in very large numbers. In fact, these drones have made a defensive term such as air denial more fashionable than offensive terms such as air superiority and air dominance. In fact, cancellation of certain high-profile projects in America of aircraft development elude that B-21 and F-22 may be the last of the big aircraft, manned aircraft, that we'll ever see coming from that country. And these small FPV drones have muddled up the new space that we call now as the air littoral. The threat from that is live and present, and we must prepare to deal with it. As Army Air Defense officer, I visualize my aim or my job to be prepared to deal with the entire spectrum of conflict from the top right to the bottom left. Sorry. Now, while studying these lessons from these conflicts, we must be rather careful, rather cautious, so to say. The lessons that have been brought forth by use of systems like Iron Dome, David Sling, Arrow 2 and 3 by Israel have alluded to some sections in India that India must build a AD wall. It should have high-profile systems deployed in layers. We should be guarded in taking such lessons, because it must be remembered that Israel is less than 1% of India's size. It is enough for 10 fire units of Iron Dome to cover all the priority 1 ingress into Israel. Moreover, its vulnerability is its population. It needs to stop the rockets falling into its country. While in our case, our vulnerable areas include the ones which are with the maneuvering forces, that is the army in the tactical battle area, and obviously our industrial capacity and the population. So while the AD wall is a welcome thing, but it must be remembered that as far as India is concerned, it would be cost prohibitive. And if we are able to put together this wall in some manner, there would be certain gaps which would exist both in low-level surveillance cover as well as the missile cover. So the lesson for me is that the point defense equipment that we have will continue to be relevant, and we must continue to invest and develop them further. Coming on to the next aspect, which are the passive sensor. For long, the radars have been the only source of information for the Army Air Defense, and which have helped us, aim our weapons onto the targets. But aim onto the targets. But what has happened is, over a period of time, the enemy has invested in tactics, techniques, which encompasses resource and procedures, and has built up a sizable inventory of land, air and space-based element capability, as well as SEAD and DRDO weapons. Now, if we are to confront this adversary armed with such an asset or array of assets, we need to prepare ourselves. In fact, we have seen this being methodically executed by Azerbaijan in the conflicts which took place in the year 2022. If we are to guard or safeguard our sensors, then we need to graduate towards multispectral passive sensors, which could take form of, or which are not limited by what are shown on the slide. That is, which could take form of electro-optical systems, passive RF detectors, and passive coherent radars, or the 3D passive radars. What I gain out of this lesson or this insight is that in future, as we go ahead, we must co-opt, or we must acquire passive systems in more and more number, co-opt them along with active system in an integrated manner, and try to use them as much as possible so as to hide our intent, location and identity. The speakers, but there are few things which I want to bring about them as far as the Army is concerned. As has been seen, first-person FPV drones, or for that matter, all kinds of drones, tactical to mid-range, are being produced and used in huge numbers in the recent conflict. In fact, economists has guessed that the number of drones being used by, or used by both the parties is in excess of 100,000 a month. It has also said that the type or the variety of these drones being used, if I total both of them or both the side, is more than 10,000. So that is the array of the threat which has come up. And as I've already said, that they offer a very lucrative replacement to a low-cost solution, or a low-cost solution and a lucrative alternative for a manned fleet. But what is certain is that, leaving apart military-grade UAVs or UCAV, or medium-range or beyond line-of-sight system, all these systems are flown by pilots, which FPV require one pilot per drone, or are flown by GCS-borne crew. But what is certain is that they have limited range. Now, if they have limited range, and if they were to be flown by adversary on the other side, then the maneuvering forces or the ground forces would certainly be in their range, and therefore a significant threat is related to ground forces by these targets, or by this entity. And that is the reason why you would notice that in the 2-3 conflicts which have gone by, barring few aircrafts which have been lost on tarmac to these drones, most of the objects which have been targeted by these drones have been elements of the ground force. So as Army Air Defense, which is the sole harbinger of kinetic kill measures, anti-aircraft measures in the Army, we must acquire counter-UAS systems in large numbers, and they must have a combination of sensors and the weapons as I have shown on the slide. Now, this is something which should interest some of you. Those are people who should be interested are outside the, because most of the vendors who have put their cubicles are in this business. But I'm here to give a little contrarian view. Now, if you can, if you pay attention to the left-hand side of the slide, the armed forces, all three of us, as well as most of the central forces, employ counter-UAS systems. And almost, in fact, all of them, barring few, employ soft kill measures. Soft kill means jamming, spoofing, and such like measures. Now, you would remember incidents of the year 2019, where you had certain electronic warfare equipment being deployed by Russian forces in Khamim air base in Syria, and that caused disruptions in GPS all the way down to Ben Gurion Airport at Tel Aviv, which is about 400 odd kilometers south of that airfield. So the point that I want to come to is that electronic attack has distant and unintended impact, which may not be welcomed by all the parties to that attack. Now, if these soft kill weapons are used in our parlance in India in an uncontrolled manner, there is a potent and a significant risk of fratricide, which we must guard against. Now, if that is to be controlled, there has to be control over flying of rather friendly flying, as well as control of deployment of or employment of such weapons. And therefore, there is a need for unity of control by our AD CNR system, which is Akash Tir, under the overall umbrella and guidance of the IACCS. If I were to guess or suggest a schema of how this thing should work, it is something, should be something as given towards the right hand side of the slide. You may have a look. Okay, enough has been spoken about the drones, but a very nuanced change is taking place over the last 2-3 years, which is that the drones are becoming resilient and autonomous. In fact, there's a stall outside which is in India, which is, I just visited that, which is making jam resistant GPS modules. In fact, he's using 4 sets of antennae to carry out nulling. Now, if that is the capability which exists in India, you can imagine the capability with China or the Chinese drones would be a little shade better or equal. Now, what is happening is, as far as the control links are concerned, and as far as the GNSS systems are concerned, they are becoming more and more resilient. You can have a look what all is being done in this field. And added to it is the element of autonomy assisted by the science of artificial intelligence. So the drones are becoming smarter. They don't need any reference to the pilot or the GCS too much. If they get jammed, they are capable of performing their mission. So what would happen is, as time goes by, as I've already brought out, soft kill is going to be becoming less and less effective, and resilience and autonomy of the drone combined with that aspect would require a different set of weapons. And I have already spoken of it a little. In my view, in times to come, it is only the hard kill means which would be effective against drones. Now we have already spoken that drones are in swarms, they are in large numbers, they are cheap. So as we go forward, these means must be cheap and they must be immediate, or they must be quick reaction or quickly deployed or employed in battlefield. Some of the means I have listed onto the right hand side of the slide. And imbibing this lesson, the Army Air Defense's focus in future would be to acquire more and more hard kill means to counter this threat. Having spoken of it, let us talk a little more on this. Now, I have tried to put together what we have learned from the lessons of the recent conflict or from the study of the operating environment. So having picked up those threads, if I were to loop them together in a beaded necklace, that necklace would look like this. Current focus of the Army Air Defense, it is for the industry which is present here, so members of it, is to acquire capabilities which are shown in this slide. And the boxes such as the RFI or the Make-2 or the RFP are is just to indicate that in that realm, either we have an RFI out or we have an RFP out. And I, as a member of the Army Air Defense, would strongly urge you to respond to them, to compete for these projects. And as has been offered in the previous session, we would facilitate your acquaintance with the requirement so that you may compete on equal ground with others. We would be interested that there is healthy competition, and we as a service or as an arm gain from that healthy competition. So these are going to be our focus area as we go ahead. The last three things should not be lost sight of. In fact, contrary to my fellow speaker, I would say that size does matter in army. In fact, my quip is that for an army, if you have a laser system which weighs 30 tons and which has to be put in 3 vehicles, it would bury those 3 vehicles in sands of desert, while those 30 tons won't matter on a destroyer which weighs 7,000 tons. So I for one make this comment that unlike Navy, we have problem of space and weight and power. They have huge power, generating capacity. If a laser requires 90 kVA 2 generators, then they take up 1 vehicle. In their case, one LM2500, if it all spare, or a chota mota gas turbine will generate 10 times the power which will require by this particular laser system. But please be conscious that when you make something for the army, make sure it is small, light, nimble, and less power hungry. Military grade reliability needs no elucidation. We have systems which need to move over all terrains. So kindly make sure that they don't break down or because of vibration or movement. High altitude operations are very important now. You have to understand that if army has to buy matchsticks today, we will surely do a trial at Leh. So even as low tech as matchstick, we are doing trials in high altitude. We want our system to be capable of operating along the northern borders. So make sure that whatever you do, the systems or the spare parts, or the parts or the sub-assemblies that you build into your system, make sure they are compliant for operations at such altitude and temperature. And be prepared to move ahead along with us as parallel development, because we are seized of the fact that it's good to have small inventory. So if we buy something, we would like you to develop another version of it or a mark of it. We would like to buy it maybe after 2-3 years, and that is how we like to go forward as far as procurement is concerned. Now, having given you a focus, it is time for me to tell you what are expectations. Now, these expectations are born from our experience, and our experience has shown that these are the challenges that industry needs to overcome immediately. It is often noticed that technical compliances or quality compliances take time to come, or they are non-existent. Your products, to some extent, are not designed for the soldier. They are not ergonomic, they are not comfortable, and they are not for for long-term use. Obviously, military grade ruggedness is yet to come in the industry, Indian industry. You must take lessons from Russian-made equipment. If there is a switch in MiG-21, which my fellow panelist has flown, you can come to my regiment. There would be similar switch in my equipment, and it would have easily had maybe 2 lakh or 3 lakh cycles of operations in last 20 to 30 years. It is still not broken down and it doesn't require a change. So look into this aspect. System engineering and project management is very important. As in the last panel, the chair remarked that delay in certain projects is not because of technological challenges, it is because of administrative reason. In fact, he was referring to this point, that we start projects, take funding, and we are not able to complete it in time purely because we are not able to manage the project, which ultimately leads to the next trap, which is time and cost overrun. And last and not the least is that you need to be committed to sustain this weapon system for 20 to 30 years. We are not a rich country. If we buy something, make sure, like we marry for life, we buy a weapon system for life. So we want it to be sustained for at least 20 to 30 years. And I leave you with my last slide. These are the technologies, these are the capabilities that the Army AD is short of. If you invest, if you focus your R&D in these domains, it would reap a rich dividend for the Army Air Defense in particular and the armed forces in general. And if we are successful, then I'm sure our country will benefit as a whole and our reliance on foreign partners will reduce. So have a look at it. I have divided them into 7 parts. These are something which you may consider depending on your line of business, background and expertise to work a little on, which will surely benefit. With that, I've come to the end of my presentation. Any question that you have, we would answer when the chair asks for subsequently. Thank you.
Good evening, ladies and gentlemen. I know it's been a very long day, but I think the Q&A session at the end of every session that we had shows the deep interest that people have in the business of air defense, even after such a long day over here. I am not going to, I am not in a position to sum up all that has been said today, but I'll just talk of a few key takeaways which were mentioned, in the morning when Vice Chief said that we need to constantly innovate, modernize and keep pace with the technology, lest we be left behind the curve, and this is something that we need to do. Also, this forum provides an opportunity for all of us, that is the industry, the armed forces people and the academia, to actually think together and hold each other's hand and move forward in the direction or the way in which we would like to go. And I think AVM Inderwalia, when in his special address, talked of air defense, that it is not defensive and it's 24/7 into 365. And I think the responsibility of identification lies with the Air Force as such. And the cycle of advancement of technology doesn't always keep pace with the cycle, with the acquisition cycle. So we have to, keep that in mind while we do that, and any product that is indigenously designed, developed, must be scalable, must be able to meet the requirements as technology keeps improving. And I think this issue of the TRL and the MRL, being at cross purposes with high TRL and low MRL, with strategic materials being imported mostly from outside, this is something that we need to keep in mind for the industry. There are many challenges. I think the entire, issues which cover the entire canvas of air operations were discussed at length today. And, from the Russia-Ukraine conflict, what lessons we need to take and how we need to be cautious of applying them in our scenario in India. I would like to thank all the people, the panelists, the chairs and the people who spoke, and the audience who asked very pertinent questions at the end of it. And I'd like to thank Major General Ravi Arora for, putting us all together and getting this. I don't know whether next time we can have a short summary of this sent to all the industry people, because they are not clear as to what our requirements are, and in some way if we can put all this together and it reaches them, and there will be better synergy as far as we are concerned. Thank you all very much, and Jai Hind.